Yes, dear students, today here I am going to start concept of work. Actually, you might have learned in different books and in classes also, but we never stress what we are doing. Actually, work means though we are working always, we am teaching you, you are learning, you are doing your job, but I am not going to tell about that work. Here I will be telling you about what is called mechanical work. Mechanics is the branch of physics in which we study objects at rest or in motion. So in mechanics we have to learn work, definition of work. So when a force acts on a body, and body gets displaced, along the direction of force, then basically work is said to be done by the force. This is basic concept of work. Work is the mechanical work. We are talking here about mechanical work. When a force acts on body and body get displaced, I have written simply in basic part, just to tell, otherwise there are many things here. I will discuss. Body may get displaced in any direction but not at right angle. Then work is said to be done by the force. So this is called mechanical work. Now in figure a body gets displaced by distance d. I have written displacement vector here and force vector this side. There is angle theta between force and displacement. But I have written that body gets displaced in the direction of force. Basic thing is that. Then to find the work done, in fact, we take component of force along the direction of force. This is another displacement, F cos theta. So now body gets displaced in the direction of F cos theta. So here, if in figure body gets displaced by displacement d under the action of force F, while angle between vector F and vector D is theta, then we take the component of force F along vector D or vice versa. Means we can take component of D along force. The same thing you will get. But here, for sake of simplicity, it is easy to understand because the component displacement and force this way. So it appears a body going somewhere else. If in figure body get displaced by displacement D under the action of force F, while angle between F vector F and D is theta, then we take component of force along displacement D, and the product of magnitude of force in the direction of displacement and magnitude of displacement will give the magnitude of work done. Magnitude is quantity of work. How much work has been done, that is measured, because physics is the science of measurement. So how to measure work? So work is measured as the product of force. In figure it is F cos theta into D. Magnitude of component of force along displacement vector, and magnitude of displacement W is equal to FD cos theta लिखते हैं, और W is equal to FD cos theta. I have told vector product, so W is equal to F dot D भी लिखते हैं. Very general definition of work. Very general definition of mechanical work is the dot product of force and displacement. Please try to understand. Everything in physics is very important to learn higher physics. Here you are learning basic fundamentals, totally basic, which will be used in your higher education, and you may understand what is happening around us. Unluckily people do not understand what we are studying. They only learn the words and letters. That is not sufficient. We have to understand. So W is equal to F dot D is the general definition of work done, and magnitude is given by this equation. Now here it is very important to understand certain facts. Now here, number one, if theta is equal to 0 degree, means displacement and force are in the same direction, then W is equal to FD, and this is positive work. What does it mean? It creates a lot of confusion further in physics if we don't understand the real meaning. Positive work means, work is done by the force. It means when force and displacement are in the same direction, then work is said to be positive. But there are other factors also which decide work negative and is positive. Though work is scalar quantity, but it has negative positive sign. When work force and displacement are in the same direction, I am telling here the work done by force positive. But there are two different type of forces also, attractive, repulsive. Work done by attractive force again taken negative, because we are measuring work done by us. If we get work from somewhere else, that work done for us taken negative also. But here in this definition, if force and displacement are in the same direction, then work is said to be positive. Now number 2, if theta is 180 degree, means force and displacement are in opposite direction, then W is equal to FD cos 180. Cos 180 degree means -1, so minus FD. Negative work. Negative work. Negative work means, it means work is done against the force. Against the force. Here is very simple example. When you lift any mass vertically upward, there are two forces on the body. One force applied by you and gravitational force. Earth attracts everybody towards the center. That force is called gravitational force. So work done by you in lifting the body is positive. But that work is being done against gravitational force because that is acting downward. By here the earth, you are taking the body up. Gravitational force this way. Gravitational force downward, but body displaced upward. Suppose it goes here, then this work done against gravitational force is taken negative. Work done by force, if force and displacement are in same direction, positive, and if force and displacement are opposite direction, work done negative. This is very important here to understand, but I told you further we will come across different situations. Now if theta is 90, if theta is equal to 90, that is vector F perpendicular to displacement, then W is equal to 0. Very surprising. If you put some load on your head and take it horizontally a distance of 2 meter, 3 meter, or kilometer, no work is done by the force applied by your body on the load, because your body is applying force vertically upward to balance the weight. In that case, you have not done work, though you are tired and may feel exertion, but this is here to understand other factors. For example, our earth moves around the sun. Our earth moves, ये sun है यहाँ, earth moves on circular orbit nearly, and in last chapter we have told when a body moves circular path, that is central force, and central force act toward the center. So that force will be obtained from gravitational pull between earth and sun. Velocity this way. Direction velocity is the direction displacement. So here force F, gravitational force applied by sun on the earth, are at 90 degrees. So no work is done, whether it moves from this point to this or complete circle. Sometime when we ask how much work is done by gravitational force applied by sun on earth. So zero answer is there, but they give the wrong interpretation. कि complete circuit displacement zero, क्योंकि displacement भी एक factor है. F d cos theta, work done zero होने के लिए ये भी है एक factor. लेकिन but here, if I ask how much work done in quarter rotation or 1/8 of the rotation, again everywhere the force is at right angle to velocity, and hence force is at right angle to displacement. So work done again zero. Similarly, electron revolve around the sun, around the nucleus of atom in circular orbit according to Bohr theory. There, the force of attraction due to nuclear charge does not do any work in moving the electron. So these are some examples. That's why we are talking about mechanical work. I think it is clear. Now, work done zero. कब होगा? When the work done is zero. But theta 90 is one factor. But displacement zero, so we work done zero. If I keep on pulling this wall, the wall is not get displaced. Then work done zero. Somewhere displacement is there, but work done zero. Why? Because like when we slip over a frictionless surface, no force act. So then in slipping a certain distance, no work is done. So this, please note this thing. Not only when theta 90. ठीक है, we will, है ना? So this is the work done. Now I think this is definition. Now units and other thing will be in other video. I can finish it here. Unit of work. Unit of work. In MKS and SI system, you understand MKS meter kilogram segment internal system. Unit of work is joule. Small j is joule, written by capital J. In CGS, unit of work is erg. Now we may define here W is equal to suppose FD, theta is equal to 0. So if a body of is displaced, if a body is displaced by 1 meter by force of 1 Newton, then work done by force is 1 joule. Similarly, if a force of one dyne displaces a body by 1 centimeter, then work done by force is 1 erg. Here you can establish relation between the two. 1 joule in fact is 1 Newton into 1 meter. 1 Newton 10 to the power 5 dyne into 100 centimeter. So it comes out 10 to the power 7 dyne into centimeter. 10 to the power 7 means 1 crore. So it appears that work is, joule is very big unit. But understand how much work is 1 joule practically. I have told you many times how big is 1 Newton force, how we realize it. W is equal to mg. If I take g equal to 10 meter per second square and I take m 100 gram, 0.1 kg, 100 gram weight we have seen. Put in your palm, 100 gram mass. That mass will apply force of 1 Newton vertical downward. So if you take that 100 gram mass, a distance of 1 meter vertically up, then you have done 1 joule of work. So that way joule is not a big work. It is small unit of work. So this was about unit of work, joule and erg. Relation is there. Have you got how big is 1 Newton? If you put mass of 100 gram on your palm, it is nearly 100 gram. But I don't feel any considerable force. If you put a mass of 1 kg, then your force of 10 Newton. And if you displace that 1 meter, then 1 kilogram mass is displaced vertically, then 10 joule of work. And you put 100 gram mass and raise it a distance of 1 meter, then you have done 1 joule of work. So joule is not a very big unit of energy or work. I will come in the next video, work done by variable force. Thank you.